6F, projectile motion, object shot up and out. Remember, a projectile is an object that travels through the air with no force acting on it other than gravity. When we investigate this type of projectile, we will again ignore the force that gave the object its initial velocity, the shooter or the gun. This type of projectile will travel in two planes or dimensions, and in three directions. In the x-plane or the horizontal, it will move forwards. In the y-plane or the vertical plane, it will initially move up, stop, and then move down, similar to the projectile shot straight up and down. This type of projectile will also have an initial velocity that is not equal to 0. Let's take a look at this example of a cannon shooting a cannonball upwards and out. Now remember, Newton's first law states an object in motion will stay in motion, continuing in the same direction and at the same speed. He also stated that an object at rest will stay at rest. These two conditions are true unless there is an unequal force acting on the object. Based on this law, if there is no forces acting on the cannonball, then once it has been shot out, it would continue in a straight path traveling at a constant speed. However, no, this is not the path that we see on Earth. Rather, what we see is a shape more similar to this curve. Just as with the projectile shot straight out horizontally, the horizontal velocity, called the horizontal component, will remain a constant under ideal conditions, while the vertical velocity will change at a rate of negative 9.8 meters per second squared, where the negative means downwards. This is also known as gravity. So returning to our image where the green arrow represents our initial velocity, let's assume the initial velocity is 70 meters per second. We will also say that the angle of inclination, or the angle of incline, is 40 degrees. But to do so, we need a horizontal reference line, which we have drawn in black. Now we can label the angle theta to be 40 degrees. Please note that this drawing is not to scale. Using our trig ratio, specifically cosine, we can determine that the horizontal part of the initial velocity, also known as the horizontal component, is 54 meters per second to the right. We label this v subscript ix, where I stands for initial and x means in the x-axis. Using the sine law, the vertical component v subscript iy is 45 meters per second upwards. Now as the cannonball travels up and to the right, the only velocity component that will change is the y component at a rate of negative 9.8 meters per second squared. So when the cannonball arrives at the top of the curve, denoted with the subscript t, the vertical velocity at the top, v subscript ty, is 0, while the horizontal velocity at the top is still 54 meters to the right. Since the vertical velocity is 0, then the total velocity at the top is simply the x component at the top. V subscript t equals v subscript tx. Now as the cannonball continues to the right, it will now gain velocity at the rate of negative 9.8 meters per second squared. And by the time the cannonball arrives at the target, which happens to strike at the same height as its launch height, it has the same speed as the initial speed. The vertical component of the final velocity will be same as the vertical component of the initial velocity, simply in the opposite direction, as they travel the same distance up as down and gravity is a constant. And the final horizontal velocity will be the same as the initial horizontal velocity, since it is a constant in all projectiles. This also implies that the angle that the cannonball strikes the ground should be the same as the angle of launch, which is 40 degrees. So when we compare the initial component velocities with the final ones, we see that the magnitudes are the same, simply in different directions. The initial and final velocities have the same magnitude, as are the initial and final x and y component magnitudes. This image illustrates the changing vertical velocity components as the object travels through the air, while you can notice that the horizontal components remain the same. The red arrow is the resultant velocity as the vertical velocity changes and the horizontal stays the same. So to recap, the initial velocity of this projectile is not 0 and is composed of x and y components. Initial speed and final speed are equal if final height equals initial height. The x component velocity, or the horizontal velocity, does not change, it's a constant. The y component velocity, or the vertical velocity, changes at the rate of gravity, which is negative 9.8 meters per second squared. At the top of the arc, the y component velocity will be 0. We can also infer that the time up for the cannonball will equal the time down for the cannonball, and also the distance that the cannonball travels up will equal the distance the cannonball travels down, as long as it lands at the same height as where it began. Here's a cannonball video illustrating the changing vertical component velocities, while the horizontal component velocity remains a constant. You can also see the effect on the resultant velocities during the trip. Watch it a few times, first focusing on the x values, then the y values, and finally the resultant.